Hi everyone, my name is Sophie Kujawski and I'm a geoscience major. My STAR project this summer is mapping the continental oceanic transition subsurface of the Cameroon volcanic line. The CVL is a chain of volcanoes located in Central Africa, extending into parts of Cameroon, Equatorial Guinea, and Nigeria. Since it's within the African tectonic plate, it's an example of intraplate volcanism, and it's also unique worldwide for spanning both continental and oceanic crust. Not a lot is known about its origin because typical explanations of similar structures don't match with our documented knowledge. So the question is, what is the mechanism that drives volcanic activity in the CVL? To start to understand this question, my research aims to understand the subsurface of the CVL, in this case, the continental oceanic transition zone. For this project, I'm drawing from two data sets. One from a seismometer network located in Cameroon during 2005 and 6, and the other located in Bioko, Equatorial Guinea from 2017 to 2019. Unfortunately, epicenter accuracy decreases when moving away from the instruments. So to account for this, as well as to focus my area of study, I restricted the data to a coordinate box of 2.5 to 4.5 latitude, 8 to 10 longitude, as well as a maximum depth of 60 kilometers. Analysis was then conducted using Excel and ArcGIS. So during the project, I then had three main questions. First of all, what does the collected database indicate about the subsurface structure of the CVL? Second, does the indicated structure change between continental and oceanic territory? And finally, how do the two data sets compare? In my time analysis, I graphed events over time relative to magnitude. For the Cameroon datasets, there was a continuous window of data collection with events concentrated at a magnitude range of roughly 1.5 to 3. There was a high event frequency between April 2006 and July 2006. Bioko data collection was pretty segmented due to rain and vandalism. Compared to the Cameroon data, an all-around smaller range of average magnitude was observed, usually between 0 and 2.5, and there were two periods of high frequency between November 2017 and January 2018, and then again during November 2018 to February 2019. Moving on to the maps and depth cross-sections, both datasets followed a similar location pattern. In both, events were clustered to the southeast of Bioko Island and also to the south of Cameroon, and they both formed two columns beneath these clusters. But in the Bioko map, you'll see more of a concentrated structure between 20 and 45 kilometers below the island, which is unique from the other dataset. Since the event maps indicate areas of increased stress, they also indicate areas of greater activity. So these columns are most likely the magma chambers below these volcanoes. In the future, continuing to build on the current data set could shed some more light on the questions we have about the CVL, specifically the issue of the concentration of events in the Bioko set. We actually have a backlog of data that was supposed to be collected during March of 2020, but we couldn't get to it because of COVID-19 restrictions. So going and retrieving that data could be an interesting extension to this project. Another angle that would be interesting to explore is investigating ways to increase depth capabilities given the current network setup, as right now there's only relatively shallow data available. Thank you for your time.